Hello kids, today we have read Science book class 6 chapter number 10 Measurement of Distance and Motion. Warm up. Observe the movement of their three hands of a wrist watch figure 10.1 on the dial. Now answer the following questions. Do all the hands of a watch move from one place to another? Which hand of the clock move? Slowest, fastest. Figure 10.1 A wristwatch with three hands. In this chapter, we will learn that motion refers to the changes in position of an object with time. The change in position can be found by measuring distance. It helps us to know how fast or slow a motion is. People have been traveling from one place to another since ancient times. During those times when no mode of transport was available, people had to walk from one place to another. Later on, people started using animals such as horses, camels, and elephants for transportation. People also used boats and rafts for transportation in water bodies such as rivers. The early boats were simple and made by hollowing out tree trunks. The invention of the wheel, figure 10.2. See the figure 10.2, the invention of wheels brought about the first revolution in transportation. It started with the use of cart driven by animal. People employed carts and chariots to travel from one place to another. This made transportation of goods and people much easier. Revolution in transportation came with the invention of the steam engine. It was Thomas Newcomen who made the first particles steam engine about 300 years ago. However, the steam engine designed by James Watt in England a few years later was completely functional. With the introduction of petrol and diesel, the time taken to travel to distant places was further reduced. Motorboats and ships came to be used as means of transport on water. Development of the electric trains, monorails, supersonic aeroplanes, and spacecraft are some of the latest modes of transportation. Distance. The length of the space between 2 points or two space is known as distance. If the two points or two places are close by, then the distance between them would be small. In case the 2 points or two places are far off, then the distance between them would be large. The terms distance and length are used in the same sense. Measurement. Measurement refers to the process of comparing an object with some standard unit of measurement. Measurement is one of the most useful process in science and in our daily life. We all make measurement in our daily life, whether we are in a laboratory, factory, shop, or at home. You get up in the morning, get ready, and go to school. At what time should you get up? How long do you take to get ready? These questions are related to measurement of time, How much distance do you have to walk or travel from your home to the school? This involves the measurement of distance, length. When you buy fruits and vegetables, the shopkeeper measures the quantity. This refers to the measurements of mass. When you fall ill, the doctor measures your body temperature. If any of the measurements are wrongly recorded, it will be result in great confusion. All these examples show that measurements have become part and parcel of our life these days. The measurement of a quantity has two parts, unit and the numerical value. The standard of physical quantity in terms of which a quantity is measured is called unit. The value of the quantity is decided in terms of this unit. The quantity can be measured in multiply of this unit. The value of the number of times the unit is responded it measuring the quantity is called numerical value. For example, if the length of your classroom is 6 meter, then 6 is the numerical value and meter is the name of the unit. Thus, measurement is the comparison of an unknown quantity with some fixed quantity of the same kind. Measurement is complete only if it shows the numerical value and the unit. Otherwise, it is incomplete or erroneous. See the activity 1. Need for standard unit of measurement. It is difficult to make accurate judgment about an object without taking actual measurement. You can't find the length, area, volume or mass of different objects by just looking at them. You can't really on guys' work. Your natural sense may mislead you at times, so for making your judgment accurate and more reliable, actual measurement of the object must be made. Thus arises the need for a standard unit. In olden days, people used to unit of different body parts of measure length. A cubit is the first recorded unit of length. The length of 1 cubit was taken from the elbow to the fingertips. This unit of length was used in Egypt and in other parts of the world. A variety of objects are used for the same measurement. For example, to measure length, you may use footstep, pace, arms length, cubit or handspan. Here the length of each of these items is a unit of measurement. Handspan is the length between the tip of the thumb and little finger when stretched. Arm length is the length between the shoulder and middle finger. Footstep is the length between the thumb, toe and the heel of the foot. These conventional methods figure 10.4 employed for the measurement of length are not satisfactory because length of arm, foot and handspan vary from person to person. So these can't be used as a common unit of measurement. Likewise, for measuring milk, we can't use a spoon or a thimble as a unit. See the activity 2. We can't accept the outstretched palm, foot or cubit as unit of length. These units of measurement are unreliable because these parts of the human body differ in length from person to person. For uniformity and convenience, a common unit is necessary for the measurement of length. Also, for day to day buying and selling in the market, we require some standard unit of measurement. Standard units of measurement. The standard unit of measurement has the following features. It is convenient to use. Its value does not change with time and place. To make measurement more scientific, uniform and convenient, the French Academy of Science introduced the metric system based on the decimal system in 1791. An international system of units called the SI system of units was adopted in 1960. SI is the abbreviation of System International D. Units in French. Table 10.1 lists common physical quantities and their SI units. Table 10.1 Physical quantities and their SI units. Multiplies and submultiplies of units of measurement. For the measurement of larger and smaller quantities, we use multiplies and submultiplies of the unit respectively. For example, the distance between Delhi and Amritsar is 4,50,000 meters. Is it not more convenient to write 450 kilometers? It is interesting. Light year is a unit of length. It is the distance travelled by light in 1 year. 1 Ly is equal to 9.46 multiply 10-15 meter. Brain treasures. Swati thought that the meter rule that the uses in India and the one used by her cousin residing in UK will give different measurement. Is she right in thinking so? Discuss your answer in the class. Standard units of length. Standard unit of length and their converses are given in table 10.2. Table 10.2 Conversation of units of length. Rules of writing the symbols of units. Following rules must be reminded while writing symbols of units. Symbols should never be followed by a full stop. Symbols are generally written in small letters. Symbols are never written in plural. For example, we write 1 meter as well as 10 meter, not 10 ms. Symbols derived from the names of scientists are written in capital letters such as Newton and Kelvin K. However, when these units are written in words, they are written in small letters such as Newton and Kelvin. Measuring length. Common instruments for measuring length. Figure 10.6 are the meter, scale, meter ruler. Tape measure the measuring. Tape and 15 centimeter rulers that is present in our geometry box. See the figures 10.6 some common instruments for measuring length. Measure tape, ruler, tape measurement. The kind of instrument we choose must suit type of measurement we wish to record. For example, we can't measure the circumference of the wrist using a ruler. We will have to use a measuring tape. Measuring tapes are commonly used by tailors. The meter rules is used to measure length of cloth, rod and pipe. It has an arrow at both ends. Rulers generally have centimeters and inch, marking 1 inch is equal to 2.54 centimeter. Points to be kept in mind while measuring length. Following points must be kept in mind while taking measurement. The placement of the ruler should be made along the length you wish to measure, as close to the length as possible. Figure 10.7 in case. Figure 10.7 to be take correct measurement. You place the ruler at an angle or at a distance from the object. The measurement will be incorrect. The length of the object is known by reading the scale division that coincides with the right end of the object. The position of eye must be actually above the point where the measurement is made. Figure 10.8. It is advisable to keep one eye shut while recording the reading. In order to measure the length of an object, we placed the scale or ruler along the object in such a way that the zero of the scale coincides with the left end of the object. Figure 10.8. The position of the eye must be exactly above the point where the measurement is made. Ensure that ends of the scale are not worn out. In cases where you can't see zero mark, clearly take any other full mark, say 2 cm. Figure 10.9. The subtract to form the reading at the other end. For example, if reading at the other end is 7 cm, then the length of the object will be 7 minus 2 cm is equal to 5 cm. Figure 10.9 measurement using a ruler with wrong edges. The length of the object should be measured using different position of the scale and then their averages should be calculated. Now, keeping the above points in mind, measure the length of your science textbook using a scale. The length of science textbook is equal to centimeter. See the activity 3. Importance of estimation. Often in daily life, we use estimation of approximations about measurement. For example, we estimate the length of cloth required to make curtains, the amount of salt required to be put in curry, the number of glasses of lemonade required in a party, the time it will take for you to reach school from our home. Estimation is a rough calculation of quantity, of extent or value of something. We use estimation when it is not possible to measure easily or when exact measurement is not required. On the other hand, a medicine is made using exact measurement of chemicals. Otherwise, it may harm the person taking it. Thus, the skill of estimation is important. This skill comes with parties, and experience. Rest and motion. We see many things when we look around the classroom. All these things do not appear to move. They are said to be at rest. For example, the blackboard in the classroom is at rest. The teacher's table does not move from its place and can be regarded at rest. Books lying on the teacher's table, if not disturbed by anybody, will not change their position with respect to the table. A body is said to be at rest when it does not change its position with respect to its surrounding. So, a teacher's table is at rest with respect to the blackboard in the classroom. Also, the books on the teacher's table are at rest with respect to the table itself. On the other hand, a ball moving on the ground, a car moving on the road, a child cycling on the road, a child running in the playground, and fish swimming in an aquarium are all in motion. Figure 10.11. Figure 10.11 Things in motion. A body is said to be in motion when it changes its position with respect to its surroundings. See the activity number 4. See the activity number 5. Rest and motion are relative terms. Suppose you are sitting in a moving car. You are in motion with respect to a pole or a tree which is outside the car. Your position is changing with respect to objects outside the moving car. However, if you compare your position with respect to object inside the car, that is the driver, the walls and the roof of the car, your friend sitting next to you, it is not changing. So, in relation to these objects, you are at rest. Therefore, an object can be in motion with respect to one set of objects, while it can be at rest in relation to another set of objects at the same time. Thus, we can easily conclude that rest and motion are relative terms. Types of motion. We have seen that motion of a body involves continuous charge in its position with respect to another body. We have also observed that different moving objects have different kinds of motions. Some of the important types of motions are translational motion, circular motion, rotational motion, periodic motion, and non-periodic motion. Translational motion. The type of motion is which all particles of a body move the same distance in the same interval of time is called translational motion. For example, a bicycle moves as a whole, that is, all parts of the bicycle cover the same distance in the same interval of time. Thus, a bicycle undergoes translatory motion. Translatory motion can be of two types: rectilinear motion and curvilinear motion. Rectilinear motion. The motion along a straight line is known as rectilinear motion. In other words, when an object moves along a straight path, its motion is called rectilinear motion. It is another name for straight line motion. Motion of car on straight road. Motion of a ball rolling on the ground. Motion a bullet fired from a gun. March past of soldiers in a parade are all examples of rectilinear motion. Figure 10.13. Curvilinear motion. When a body moves along a curved line, it is said to be curvilinear motion. For example, the motion of a car on a curved road and the tip of a pencil while writing are some examples of curvilinear motion. Figure 10.14. Circular motion. When an object moves in such a way that its distance from a fixed point remains the same, the object is said to be in circular motion. Motion of the moon around the earth around the sun, the balance of a moving fan, the hands of a watch, a child sitting on a merry-go-round are all examples of circular motion. Figure 10.15. See the activity number 6. Rotational motion. When an object turns or spins about a fixed axis, its motion is called rotational motion. The spinning of the earth on its axis is an example of rotational motion. A spinning top also shows rotational motion. Turning of a potter's wheel, turning of a bicycle wheel, turning of giant wheel are all examples of rotational motion. Figure 10.16. Some example of rotational motion. Get it right. The difference between circular motion and rotational motion must be kept in mind. In circular motion, the object as a whole travels along a circular path, but in rotational motion, the object spins about its axis. Periodic motion. The motion which repeats itself after regular intervals of time is known as periodic motion. The revolution of the earth around the sun is a periodic motion because the earth always takes the same amount of time, that is 1 year, to complete one round around the sun. Also, the earth always takes the same time, that is 24 hours, to rotate it the once on its own axis. So, the rotation of the earth on its axis is also a periodic motion. Motion of second hand, minute and hour and of a watch, revolution of the moon around the earth, swinging of a pendulum, vibration of the stretched membranes of a drum when struck are all examples of periodic motion. Figure 10.7. Non-periodic motion that does not repeat itself after regular intervals of time is called non-periodic motion. Some of the examples of non-periodic motion are blinking of eyes, occurrence of earthquake, and playing football on the ground. Objects showing more than one type of motion. An object can have more than one type of motion at the same time. For example, the earth has 3 types of motion: circular motion, periodic motion, and rotational motion. The earth rotates rotational motion about its axis, and at the same time it revolves around the sun in circular path, circular motion, and takes 365 days to complete one journey around the sun. Periodic motion. When you ride a bicycle, the wheels not only rotate but also move forward. So, the wheels have rotational as well as translatory motion. At the same time, such a motion where the body undergoes both translation and rotational motion is called rolling motion. In a running sewing machine, the wheel has circular motion, but the needle moves up and down periodic motion. Figure 10.18. In a running sewing machine, the wheel shows circular motion while the needle shows periodic motion. Science vocabulary, it means keywords. Measurement, the comparison of an unknown quantity with some fixed quantity of the same kind. Distance, the length of the space between 2 points or 2 places. Cubit, the distance between the tip of the middle finger of an outstretched hand and the elbow. Standard unit, the unit of measurement which is universally accepted. Rotational motion, the motion of a body about some fixed axis. Circular path, the round path having the shape of a circle. Rolling motion, the motion of a body that undergoes both translatory and rotational motion. Thank you.